let's solve some equations. So this is from section 3.3 of your book. We're going to solve linear equations that just have one variable that is unknown. We're going to do some proportions. And of course, we are always going to make sure that it makes sense in the context of the situation. Okay, so the question is it still an equation? Okay, and by equation, I mean a true equality. So 6 take away 2 equals 4. Yeah, that checks out. That is an equation, a true equation. Add 2 to both sides of the equal of number 1. So let's go 6 minus 2 plus 2. And 4 plus 2. Well, 6 minus 2 plus 2 is 4. 4 plus 2 is 6. 4 plus 2 is 6. So, yes. But now up here, this actually says 4 equals 4, right? And by doing this in number 2, adding 2 to both sides of the balance of equality, we're really saying, yes, if 4 equals 4, then 6 equals 6. Okay, subtract 10 from both sides of number 1. Okay, so let's see. We start with 6 minus 2, subtract 10. And does that equal 4 take away 10? Well, 6 take away 2 is 4. 4 take away 10 is the same as 4 take away 10, which is, by the way, negative 6. Right. If you want to view this as 6 take away 12 is negative 6, fine by me. But nonetheless, this answer is yes. But now what this is reading is negative 6 is equal to negative 6. If we started with 4 equals 4 and we took away 10, well, now we're below, so we're in the negative side, but we started at 4, so now we're saying negative 6 equals negative 6. Multiply each side of number 1 by 8. All right, well, so that would look like 8 times 6 take away 2. And the question is, does that equal 8 times 4? And the answer is yes, because by order of operations, we would do the parentheses, which is 6 take away 2 is 4, and then 8 times 4 is 8 times 4, which, by the way, is 32. If you distribute this, so side note, if you go ahead and distribute, what would you have? 8 times 6 makes 48. 8 times 2 makes 16. 48 take away 16 is again equal to 32. So regardless of whether you distributed or followed the order of operations, here number 1 really said 4 equals 4 just in a weird way, and now number 4 really says 32 equals 32, but in a weird way. Divide each side of number 4 by negative 4. Okay. So number 4 looks like this. 8 divided by 6 take away 2 divided by negative 4. Did I say 8 times or did I say 8 divided? 8 times the quantity 6 minus 2 all divided by negative 4. Is equal, or we're questioning the equality to 8 times 4 divided by negative 4. Well, I still say yes, because over here this numerator will be 32. 32 divided by negative 4 is the same as 32 divided by negative 4, which, by the way, is negative 8. So this really would read negative 8 equals negative 8. Because in number 4, we had 4 times 8 is 32 equals 32. And then in number 5, we really just divided both sides by the same amount. Add 17 to the left and to the right of the equals sign in number 5. Okay, so it's gonna look messy. It's fine. So the left side of the equals would look like 8 times the quantity 6 minus 2, all divided by -4, but then add 17. And does that equal the quantity 8 times 4 divided by -4 plus 17? And again, I would say the answer is yes. I think I forgot to put a yes for this one. But, like I said, we have to follow the order of operations. Remember, the order of operations says there are these implied parentheses around numerators. So we really do all of that first. So we would do 6 take away 2, we would get 4. Then we would do 8 times 4, we would get 32. 32 divided by -4 is -8. And then -8 plus 17 would be 9. And over here, we would do, so implied parentheses around this numerator. We would do 8 times 4 is 32. 32 divided by -4 is -8. -8 plus 17 is 9. So the answer again is yes, but then this would be 9 equals 9. Okay, so here's what's up. When we're talking about, when we know things are equal to each other and we do something equally to both, so we add 4 to both, or we quadruple in both sets of equal value, or we add 17 to 2 sets of equal value, then they still have equal value. It's just that they have a new, different amount of equal value. So instead of having -8 each, now all of a sudden they have 9 each. But they still maintain their equality. So we have these properties of equality. Will they still be equal in value even though we have either scaled them up, scaled them down, added or taken away? And the answer is yes. So the additive property of equality is if you add or subtract the same amount from both sides of a true equation, it will still remain true. So if the same amount is added or subtracted from both sides of a true equation, both left and right, of a true equality or a true equation, then it will remain true. Or it will remain equal. Maybe a different value, but it'll remain equal. Okay, and then the multiplicative one. So even when we multiplied or divided, the same thing happened. So we would just rephrase this if the same amount is multiplied or divided by both sides of the left and right of a true equality. So if, you know what, let's put if a true equality is scaled. Which is just another way to say multiplied or divided, scaled up, scaled down, except by 0, by the way. If you multiply both sides by 0, you will get equality. You'll get 0 equals 0, but you really can't scale down by 0. Doesn't quite make sense. If a true equality is scaled, which is multiplied or divided, by the same amount, on the left and right, then it will remain equal. And then let's remember the solution to an equation. And now we're just going to be looking at equations in one variable, but still we could have equations that have more than one variable and solutions that have more than one corresponding values to each other to make equality happen. So, but nonetheless, let's put the value, and I'm going to say, or values of the variable or variables that make the equality true. Or let's say that make the equation. Is there an E in truly? Whatever. Truly equal. Okay. And we've seen that before, but I'm just bringing it back as a recall. Let's look at the value of a tool. The value of a tool is given by the function V equals 10,000 minus 50t, where t represents the number of years since 1990, and V represents the monetary value of the tool. Create a table to keep track of the value, then use it to predict the value of the tool in 1992. Okay, here we go. So we've got some t to keep track of, number of years since 1990. And we have the worth of this, some kind of tool. 10 grand is probably like a robot, like a manufacturing robot. Year since 1990, and we'll go value of the tool. So I'm just going to call that worth. All right, so 0 years since 1990, or in 1990. We see that there have been 0 takeaways of 50, so it's worth 10 grand. No time has passed. T is 0. At t equals 1, it started at 10 grand, it went down by 50. It went down by 150, so 9,950. At t equals 2, it's gone down by 2 50s, which is 100. So 9,900. I'm seeing the pattern already. So I'm going to quickly take away 50 every time. So 9,850, 9,800, 9,750 is the worth. Oh, we should probably put in dollars. Yeah? It says use this table to predict the value of the tool in 1992. Well, one thing that I usually like to do is just keep track of this. So if it's 0 years since 1990, then this 0 represents the year 1990. This would be 1991, 1992, 1993, etc. So it looks like the value of the tool is probably $9,900. Use your table in order to find the value of the tool in 2013. Ay, Chihuahua. Okay, so I'm going to have to keep labeling this. 4 represents 1994. 5 represents 1995. 6 represents 1996. Okay, I'm going to have to keep going here. But now I'm going to get a little bit lazier and just say T, years since 1990, and W, worth. Let's go 7, 8, 9, 10, 11. I think we have to go all the way to 13. Man, is that just going to be 2003? Ugh. Hold on. Okay, here we go. This is 1997, 1998, 1999, 2000, 2001, 2002, 2003. And we have to go 10 more? Oh, beans. Here we go. All right. Just to line these up, I feel like I kind of lost track of lining this up. This is... Okay, use my handy. Year 1, okay, 2 years, 3 years, 4 years, 5 years, okay. 9,700, 9,650, 9,600, 9,550, 9,500, 9,450, 9,400, 9,350. And then we have to do 10 more of these. Huh. Well, I have an idea. I mean, we have to do 10 more to get to 2013, and 10 50s is worth 500. So I'm going to take 500 away from here. Let's see. So I'm going to go like this. So 9,350 take away 500. Yep. It appears as though I cannot find my calculator. So it looks like I'm going by hand. 0, 5, 8, 13 take away 5 is 8. Okay. So use your table. Well, I mean, I did get a little bit tired. And then I just said, well, 10 more years would be 10 more 50s, and that's $500. In 2013, it'll be worth $8,850. All right. So instead of doing it using this table and having to keep going, use an equation and solve it in order to find this value. We got this. So first, we have an equation up here. It reads V equals 10,000 minus 50t. We also know that we're finding the worth in 2013, and t is years since 1990. Well, to get from 1990 to 2000, you go up 10 years. To get from 2000 to 2010, you go up an additional 10, and then 3 more. So t equals 23 in 2013. And let's see then. So really what we have is we are solving the equation. $10,000 minus 523 times. Oopsie, 50 23 times. And so, apparently, that is $8,850. Okay, so we had an equation. We were given, that equation had two variables in it. We were given the value of one variable and we computed to find the other variable, the value. Use an equation and solve it in order to find what the value was in 1992. Well, in 1992, which by the way, we already know the value from the table, but in 1992, we know that T is 2 because that's 2 years since 1990. So T equals 2 there. V is 10 grand, take away 50 T times. So V is 10 grand, take away 50 2 times, and so that's $100. So the value is $9,900 in 1992, which also goes along with our table. Use the table to find when the value of the tool will be 9,850. Okay, let's see. Oh, there it is, right there. T is 3, and that represents 1993. Let's write this down. Okay. When T equals 3, the value is 9,850. So the tool will be worth $9,850 in 1993. Got it. Use the equation to find when the value of the tool will be worth 8 grand. Okay, because otherwise we would have had to keep doing this list for a long time. I mean, we didn't even want to go all the way to 8,850 because it was just taking too long. So let's use the equation to do this. Okay. Our equation again is V equals 10,000, take away 50 T times. And right now, we're not given the time, we're given the value or the worth. So we are given that this is 8,000. Okay, and immediately I recognize that what this is saying is that, by the way, the difference between 10,000 and some amount is 8 grand. Well, that means this amount is $2,000. Okay, so immediately I look at this and I think, oh, so 50T has to be equal to 2 grand because then it would be 10,000 take away 2,000 equals 8,000. But I want to just tell you that most people won't do that. And when they look at this equation, most people will do this. So they will be like, okay, we have this equation. We can subtract 10 grand from both sides of this equation because we have the additive property of equality. And that will give me the new equation of what? Negative $2,000 equals negative 50T, which will then give me this equation if you multiply both sides by -1, which is true. So either way, if you want to use just like sheer number knowledge, fine, as long as you're right. And as long as you show me your logic. Like to go from here to here, I understand that logic. To go from here to here, I understand that logic. But to just go straight to a T answer, that is not really showing me how you thought about finding your answer. Maybe I would assume that you did guess and check, which means then you might get dinged because I'm testing or asking you to show me that you know how to use an equation. Nonetheless, so now since T is being scaled up by 50, we need to scale it down. So 50 times T, undo that by division. So divide both sides by 50. And what is that, 40? 40 years later? Okay, well, if t equals 40, when is the value 8,000? Well, we predict that's 40 years since 1990. 1990 plus 40 years, that's in the future. Around 2030, the value will be 8 grand. Okay. In the next video, we're going to do more solutions, but we're also going to be using our calculator in a new kind of way that I wanted to show you.